In section 1C, we have equations with square roots in them, and they do not take up the entire equation, so we have to be careful about how we solve them. We're actually going to go through 3 examples on this one, on 1, 3, and 5. So starting out with our first one, we have square root of b plus 2 equals 2. Now, to solve any of these problems, we need to square the part with the square root. We need to be able to square that so that we can make the square root go away, and then we can solve for b. In order to do that, we need to do the same thing to both sides of the equation. So we would actually have to square this entire piece. Now the problem with that is if we do that, we're going to end up having to FOIL, and if we FOIL, we're actually going to end up still having square roots, so that's not really going to solve our problem. So before we can do that, we need to get the square root alone on a single side, so that way we don't have any of that foiling. So in this case here, we have a 2 on this side. We're going to subtract 2 from both sides, and we end up with square root of b equals 0. Now, when we take our next step, when we square both sides of the equation, we'll end up getting just b over here, and then 0 squared, in this case it's 0 again, and b equals 0 would be our answer. It says, remember to check for extraneous solutions. What that means is there's times where you're going to get b equals something or x equals something, and if you plugged it back in, you're going to end up having to take the square root of a negative number. If you were to go to your calculator and type in square root of 0, it would say the answer is 0, so it's okay to take a square root of 0. But if you took the square root of, say, negative 1 or any negative number, you're going to get an error on your calculator because it is not possible to take the square root of a negative number. So to check for extraneous solutions, what you do is you take your answer and plug it back in. In this case, it's square root of 0, it's okay, so we have nothing to worry about. So moving on to number 3. In this problem, we see that we have square roots on both sides, and it actually takes up the entire side of both equations. So we can jump straight to the step where we square both sides. And when we do that, we end up with 3x equals 2x plus 1. Now, just because you see over here square root of 2x plus 1, don't think you have to FOIL it, because the whole thing is under a square root. And when you square something under a square root, all it does is take the insides and free it from the root. The square root sign and the square cancel each other out. So don't double square, I guess. Just leave it like this. And now to finish this off, it's a simple algebra problem. We take 2x away from both sides and we end up with x equals 1. In our check for extraneous solutions, let's make sure that this works. If we were to plug in x equals 1 up here, then we would have 3 times 1, and the square root of 3, although you may not know it off the top of your head, it is possible. It's not a negative number, so that's okay. And then let's try it here. If you put it in here, you get 2 times 1 is 2, plus 1 is 3. Again, square root of 3 is okay, so no extraneous solutions to worry about. And then this last one, number 5. We have the square root on one side of the equation, and there's just n on the other side. We can jump in to our next step of squaring both sides. And when we do that, on the right side, we get what we expect. We break away that square root to make it just 4n, so the square root symbol goes away. And then on the other side, we have n squared, so we literally write n squared. Now this is interesting because when you see n squared equals 4n, you might be tempted to maybe divide both sides by n right away, and then you'd get n equals 4. That will work, sort of. It does not capture all of the solutions. A better solution when you end up with a n to the first power and an n squared in the same problem is to, and sometimes you'll even have like a number like 7 or something in the problem as well, get everything to one side of the equation. So n squared minus 4n, I'm going to take away 4n from both sides, equals 0. Kind of weird, but if we go with it and we look and we go back to factoring, we say, what's in common with both parts? Well, I have an n in common, so then I factor out an n and I get n minus 4. All of this is equal to 0. And when I do this, what it tells me is if I made n here 0, 0 times anything in here is going to be 0. And in this one, if I made n 4, 4 minus 4 is 0, this 0 right here multiplied by anything over here is going to be 0. So either way, as long as either 0 or 4 is given as an answer, this equation is going to be true. And you can check this. You can plug it back into the original equation up top and say, well, if I have, let's clean up my work here. If I plug in 0, does 0 equal the square root of 4 times 0, which is the square root of 0? Well, yeah, the square root of 0 is 0, so that actually works. And in the same way, I plug in the 4. Does 4 equal the square root of 4 times 4, or the square root of 16? Well, yeah, 4 does equal the square root of 16, so that works as well. So both of these are actually solutions. So you would say n equals 0 and 4.